Good afternoon. Welcome to Intermediate Accounting and today's discussion on the time value of money. When we talk about the time value of money, a very important initial discussion is about interest. And so let's think about simple interest and compound interest. So simple interest is just like we have here in the top frame. You have an investment. Let's imagine the investment's $50,000. Let's suppose there's a 10% rate of return on the investment over a year. So 50,000 times 10% is that you'd have to pay $5,000 as interest on the 50,000. Well, now let's consider compound interest. So with compound interest, you have the initial 50,000. The first year, the rate would be 10%. You'd have $5,000 interest, but perhaps you wouldn't pay it. So instead, the new balance rises to 55,000. Now you've got your 50,000 initial investment, plus the $5,000 interest that you didn't pay last year. This creates a $55,000 balance. When you multiply this by 10%, you now owe $5,500 this year. So we call this compound interest. And compound interest is more common. Here, any balance we haven't paid becomes the current balance. All right, two concepts that are very important in considering the time value of money is future value and present value. So the future value concept gets at how much will $1,000 invested now be worth in 3 years? Well, if you can invest the money at 10%, and that's kind of high by current standards, for 3 years, you could look up at the rate in a table and find that the table value is 1.331. So when you multiply the $1,000 times 1.331, you'd come to a future value of $1,331. This says that 1,000 today, if you could invest it at 10% for 3 years, at the end of the 3 years would be worth $1,331. All right, well, now consider present value. Present value is a little bit different. With present value, you need to think about how much an amount received in the future would be worth today. So consider this like that promise. Hey, if you loan me $1,000, I'll pay it back to you in 3 years. Well, my example here is slightly different. We take that 1,331 that we're going to receive in the future. We multiply it by the present value table, or the present value table value, 0.75131, and we determine that $1,331 received from 3 years from now is worth the same thing as 1,000 today. We could use this in a variety of examples. Let's use it in this one. So now we're considering the purchase of a machine. Bill's old Southern Cookin' Buffet is thinking of buying an ice cream machine. The machine will cost $10,000 right now. So won't be any reason to look at present or future value of that. 10,000 now is 10,000. But the thing that's going to require table value of money concept is that this machine will earn 2,000 per year for 10 years. Let's imagine that the prevailing rate of interest or inflation rate is 6%. That's a lot closer to accurate today, still probably a little high. The question is, should Bill's buy it? Should Bill's Buffet buy it? Let me say one more thing about the interest rate. This rate may be perfect in the sense that although it is although it's high by very current standards, when you're thinking about what the prevailing rate is going to be, in this case for 10 years, you'd want to give some thought to whether you think interest rates will change, and if so, in what way they would change. And I think many economists think they probably won't go any lower. It'd be hard to do that. It's possible they could go a little higher. And if they do, 6% might be right. Well, anyway, let's look at the calculation to see whether Bill's Buffet should buy the machine or not. So there are two cash streams, and we need to think about each one. The first cash stream is the buffet has to pay $10,000. So clearly, $10,000 today is worth $10,000 today. But the second stream is that the buffet will receive $2,000 per year for 10 years. That's $2,000, and we're assuming they're even payments. Now, this is an assumption that very often businesses make when they're doing an analysis like this, not because the payments are perfect each year, but how would you decide? If it's about $2,000 each year, how would you decide that next year it'll only be $1,900, 2 years from now it'd be $2,100, then be $2,200 the third year, then it might drop back to $1,950 the fourth. So a lot of times, because it's the future we're talking about and there's no perfect technique, the person doing the calculation just says, let's assume the payments are even, approximately $2,000. Well, we could use table value 4, and I'm going to pull that out in a minute. Not that you'll be able to see it on the screen here. It'll be very small. But I'll give you some idea where we go to look on these tables for the values. So we're going to go to a present value table. The table we want to look at is called a present value of an ordinary annuity. In your book, it's table 4. Also, it's important to point out that this is present value of an ordinary annuity of $1. So you'll find several tables. You'll find present value of $1, future value of $1. You'd also find future value of an ordinary annuity. You'd find future and present values of annuities due. The important thing for us to realize here is that this is an annuity because it's an even payment stream for a set number of years. The fact that we have $2,000 even payment for 10 years, means this is an annuity. If we only got one lump sum at the end, we'd look at present value of $1. So we determined that $2,000, the amount we're going to receive each year, and a table value for 10 periods at 6% interest, we would arrive at the table value of 7.36009. So then what you do quite simply is multiply the 2,000 times 7.36009, and you come up with $14,720.18. That's how much we think that $20,000 received over the next 10 years, $2,000 per year, would be worth as we receive those payments. And the notice I have for you in red here is that 2,000 times 10 would have been 20,000. So this present value computation acknowledges that the future value of the 20,000 isn't worth the 20,000 today. It's worth something less. Well, this is the table reprinted from a recent edition of your book. And notice you get into this and you're looking for 6%, and I find it here. Right in this column. I'm coming down looking for 10 payments. They're here. And that's where I get the 7.36009. The book shows you a very complicated formula you could use, and we're not going to use the formula. Instead, it's most common, and this is what most accountants and CPAs face, that there are tables printed for you like the ones in the back of the book, and you should just use those. Well, here's the end game then. Since the present value of that annuity, $14,720.18, is greater than the $10,000 purchase price, by all means buy it. Well, that's one application for time value of money. Particularly in the second semester, we'll look at other applications, particularly the bond payable application. But for now, let me know if you have any questions. Take care.